of Rocky Mountain Institute, and today we'll be talking about the benefits of electrification and why cities and states in Oregon and beyond should electrify. Today we'll be talking about the general case for electrifying buildings and talking about some of the specific benefits around climate, health, equity, and affordability, and also describe some of the cost research for electrification, including incremental costs and electrification, and how that should fit within the larger framework of efficiency, renewables, and grid interactivity. And finally, we'll be talking about some recommendations for cities and states that's informed by this research. So let's dive into why we should electrify. So state level climate commitments are expanding and increasing in ambition. And you can see here in Oregon, they have goals to reduce emissions by 10% below 1990 levels by 2020 and by 75% by 2050. And so in order to meet those goals, electrification will be an important part of the process. Fossil fuels are burned in 70 million homes and businesses around the US and account for 10% of US carbon emissions. Space heating is the major source of emissions, especially in cold climates. So you can see here, space heating and water heating are the leading sources, followed by cooking. Gas is responsible for the majority of direct building emissions across the US. So you can see here, gas represents 81% to 87% of sector emissions once methane leakage and on-site combustion emissions are considered. The methane leakage CO2 equivalents show the range of values, with the 133 metric tons equaling the low leakage and the 100-year global warming potential, and 465 equaling the high leakage and 20-year global warming potential. And you can see there's a range of values that you could, but at the same time, regardless of how you do the analysis, burning gas in buildings is a major cause of pollution. So in 2018, an estimated 223 billion cubic feet of methane was leaked while delivering billions of cubic feet of gas to buildings. Reducing demand for gas can reduce emissions at various parts of the supply chain, all the way from gas production to building level emissions. Building sector emissions in Oregon have been rising in the last 2 decades. This is a problem, especially as the state strives to achieve its greenhouse gas reduction targets. And as we mentioned earlier, Oregon's goal is to reduce emissions by 75% by 2050, and it's not on track to do so currently. And right now, it's also headed in the wrong direction as the state continues to add new gas customers. This makes the problem of emissions worse. So to reduce climate emissions and to get closer to achieving the targets, Oregon will need to reduce fossil fuel use in buildings. And now I'll pass it over to Leah to discuss the benefits of building electrification.
Thanks, Neha. So for years, conventional wisdom was that piping gas directly to a building would result in lower emissions compared to burning fossil fuels in a power plant, sending them through the electric wires, and then powering an electric appliance. And that was true back when electric appliances were less efficient and the grid was less clean. But now we've made such great progress, both in technological advancements and greening the power grid, that replacing a gas furnace with an efficient electric heat pump today will reduce carbon emissions in 46 out of 48 continental states in the US, all but Wyoming and Utah, which still remain heavily reliant on coal-fired electricity. That's 99% of US homes that could reduce emissions by going all electric. And assuming the trend toward a cleaner power grid continues across the country, the savings will only increase over time. The comparison here is to gas, but if we were to compare it to fuel oil or propane heating, which are even higher carbon emitters compared to gas, there is no question that heat pumps would be the cleaner appliance there as well. Right on the slide, we're looking at the results in Oregon, which show heat pumps are over 3 times more efficient than Energy Star gas furnaces. And this trend is consistent across states. we find heat pumps range from about 2 to 4.5 times more efficient than the Energy Star gas furnace on an annual basis. Efficiency was highest in places with mild winters like California or Arizona, but heat pumps still outperform gas furnaces in cold climates like Minnesota and Wisconsin. The two biggest takeaways here are, first, electrification of residential space heating is a key lever to reduce carbon emissions. And second, there's no need to wait. Heat pump adoption in Oregon is already going to cut emissions, and the climate benefits will likely increase over time as Oregon continues to reduce emissions in its power sector. In addition to climate benefits, electrifying buildings is a critical step in improving air quality and public health. Looking first at outdoor air quality, this graphic shows data from a recent MIT study that looked at premature deaths in each state caused by combustion emissions. The study looked specifically at particulate matter, PM 2.5, and ozone, and it includes all combustion sources, including gas, wood, oil, and propane. As you see on the graph, which shows Oregon specifically, buildings are the #1 source of premature deaths from combustion emissions, greatly exceeding power generation, transportation, and industry. And in fact, the study found that nationally, a 10% decrease in building emissions would have a 3.3 times greater benefit than further reducing 10% of emissions from electric power generation. This really highlights the risk of combustion sources in buildings and the opportunity for health benefits by reducing building emissions. And again, looking here at Oregon, we can see on the graph that a fully decarbonizing and getting rid of combustion sources in Oregon's building stock can prevent over 400 premature deaths. That is something that we simply cannot ignore. Now moving indoors, our indoor air quality is often worse than our outdoor air quality, in part due to the use of fossil fuel appliances, especially gas stoves and ovens. We spend about 90% of our time inside buildings, and that was before COVID-19 hit. While we're all in our buildings, working from home, cooking on our gas stoves, we may be exposed to pollutant levels that are 2 to 5 or as much as 100 times higher than the levels of pollutants that the U.S. Environmental Protection Agency would legally allow outdoors. We're talking about carbon monoxide, nitrogen oxides, things that cause respiratory illnesses like asthma. This is an enormous and terrifying problem. And scientists have found that homes with gas stoves have 50 to 400% more nitrogen dioxide emissions compared to homes with an electric stove. Taking a closer look at the outdoor pollutant standards I mentioned, you can see in the top chart that agency standards for outdoor nitrogen dioxide range from 60 to 180 parts per billion in an hour. Indoor, the range is about 90 to 100 parts per billion. On the bottom chart, you can see levels of pollution that result from cooking on gas stoves and in gas ovens. They exceed both indoor and outdoor limits, getting as high as 546 parts per billion, well beyond the levels that our agencies tell us is safe. And with this pollution comes a serious cost to both our pocketbooks and our bodies. Australian researchers conducted a meta-analysis to determine how much childhood asthma was attributable specifically to gas stove pollution. The answer was 12.3%. That's over 12% of childhood asthma that could have been prevented by using electric cooking. Another study found that children living in homes with a gas stove are 42% more likely to experience asthma symptoms and 24% more likely to be diagnosed with asthma by a doctor compared to those living with an electric stove. Gas stove pollution is preventable. These asthma cases can be avoided. We need to electrify our kitchens. In Oregon, 10% of adults and 7% of kids have asthma. The cost of asthma nationally is about $80 billion a year. That's over $3,000 per person per year. An electric stove can cost less than $1,000. It's no question where we should be spending our money. And unfortunately, those that have the most trouble paying their energy bills today are the ones facing the highest health burden. It's often the older buildings with inadequate ventilation, typically multifamily buildings, that have the highest levels of gas stove pollution. And these are also the homes of our lower income families. But this doesn't have to be the case. A study looked at 2 public housing apartment buildings with similar characteristics and found that health impacts improved and nitrogen dioxide levels dropped by 65% when residents moved from the dirtier buildings to the cleaner and greener buildings. The study cites the swap from gas to electric stoves as a contributing factor, supported by the fact that the residents' cooking times hadn't changed. We know we can help address this pollution inequity through building electrification. Therefore, building electrification can and should be a key component of an equitable and just transition. You just heard that low-income residents face greater exposure to pollution, often due to poor building quality. And this is also true for communities of color. They're also at risk of higher than average energy bills from poorly insulated homes, a less comfortable and safe living environment, especially during periods of extreme heat and cold. Electrification can help these families by providing efficient heating and cooling and improving the affordability over the lifetime of the heat pump appliance. So policymakers and regulators should offset the higher upfront costs for retrofits for low-income communities and increase their access to heat pump retrofits. We'll also need to ensure a just transition for fossil fuel workers and others impacted by the shift by providing support and training for those workers to access high-quality jobs. Last year, over 2 million people worked in energy efficiency, more jobs than all fossil fuel extraction. Yet the COVID-19 pandemic has hurt the industry, and hundreds of thousands of energy efficiency jobs have been lost since March. But electrification can support both economic recovery and a just workforce transition. A study by UCLA found that if all new and existing buildings in California are electrified by 2045, it could create over 100,000 jobs statewide, even after accounting for losses in the fossil fuel sector. Policymakers ought to be considering funding for the clean energy sector in their stimulus packages when they work to build back better and recover their economies. And these efforts to strengthen the workforce should incorporate measures to improve workforce diversity. There are some great examples of existing efforts to train women and people of color for energy efficiency jobs by Elevate Energy and Rising Sun Center for Opportunity, to name a few. Let's build on these efforts to increase diversity and strengthen our workforce. If we do this right, building electrification can achieve multiple benefits, not only emissions reduction, better health, and improved air quality, but also economic opportunities and improved livelihoods of disadvantaged communities. Now let's take a look at the cost implications of electrifying buildings. Here at RMI, we looked at the economics of electrifying buildings from the homeowner's perspective and compared electric, space, and water heating to gas heating in new and existing homes across 4 U.S. cities. This slide shows the results in Oakland, California. On the left-hand side, we're looking at new construction, and on the right-hand side, we're looking at retrofits. The green is electric heat pumps, and the blue is gas furnaces. You can see on the left that in all the heat pump scenarios we looked at, they are lower cost than building a new home with a gas furnace. And that didn't even include the cost savings from avoiding new gas infrastructure. On the right, you see that retrofit economics are less straightforward. The heat pump wins here when compared to a home that replaces both its furnace and air conditioner, but not when it's only replacing the furnace. And now we recognize that Oregon is not California, but we wanted to show this example as they're somewhat similar in climate. Notably, we're also working on a second version of this analysis, looking at cities including Seattle, Boston, and Denver. The analysis is not yet complete, but we're seeing similar themes emerge. Space heating costs are the most variable, depending on the climate and the grid. The big drivers of the variability are the age of the existing air conditioning unit, whether the home needs an electrical upgrade, and the rate structure in a given city. Water heaters tend to have a smaller cost gap and clear emission savings. And electric new construction is consistently lower cost in emissions across the board, especially when considering the avoided cost of a new gas connection. The takeaway here is that there are some opportunities for residential cost savings from electrifying gas appliances, especially in new construction. But policymakers, regulators, and utilities should all consider how to support electric retrofits through financial rebates and incentives. Now I'll pass it to Sneha to share more of RMI's insights on cost analyses.
So we see here that the range of costs for electric, gas, and induction really vary on the upfront cost. And while induction stoves tend to be more expensive in the US, there's other countries with greater use of electric appliances, such as the UK, that have seen near cost parity and availability for induction. It's worth noting that this range does not include smaller and less expensive induction stoves. As Leah mentioned earlier, they can be less than $1,000, and that's a good starting place as well. But as the market continues to grow, we anticipate that the cost differential between induction stoves and gas currently will continue to reduce. So this study looked at the cost of heat pump water heaters, and we found that in new construction, heat pump water heaters are cheaper to install than gas systems when considering avoided gas infrastructure costs. And another important consideration is the type of system, individual heat pumps and central heat pumps, and the cost differential in the situations where we don't account for avoided gas infrastructure costs can often be overcome through utilities and governing bodies that provide incentives. For example, there are many incentives that are provided by local agencies such as BayREN, and that this can be applied to other localities as well. And it's important to consider electrification within the greater suite of decarbonization technologies. So other key levers to decarbonization include adopting energy efficiency and renewables, as well as grid interactivity. And we can see that it's important to include all of them to lower costs, improve efficiency, and lower carbon emissions. Highly efficient buildings can reduce the size of the HVAC system that's needed, and this can help improve the cost of the system and performance, while ensuring that buildings are smart and responsive and dynamically integrated with the grid can help shift loads to times where the grid is cleaner. And this can also help optimize costs and carbon savings. And especially if there's other large loads, such as electric vehicles, maintaining flexible loads can be important to make sure that we avoid large peaks from a grid distribution planning perspective. So now I'll turn it over to Leah to talk about what cities and states can do given all of this information about the benefits and the costs of electrification.
Thanks, Neha. In the absence of any sweeping national efforts to address buildings, states, cities, and local entities have really stepped up in a variety of ways. And we want to share a few examples of the actions that they've taken to support building electrification. That said, it's important to caveat that the social and political landscape varies greatly by location. So these solutions are not a one-size-fits-all, but rather a menu of options that states, cities, and local entities could explore to electrify in their region. So one important solution is providing incentives and financing, particularly to support economics in the retrofit sector. Energy Trust of Oregon, for instance, offers $250 to $700 incentives for residential heat pumps. Utilities can also offer rebates. So we've seen this in California. The Sacramento Municipal Utility District offers up to $3,000 for efficient air source heat pumps. Another financial solution is tariff on-bill financing, which we've seen used for energy efficiency, but could also be applied to electrification. This is where the utility pays for building energy improvements and recovers the cost over time through a charge on a utility bill. Zero interest loans is another way to help bring down the upfront cost of electric appliances. In addition to financing, policy and regulation are playing a critical role in building electrification. In California, we've seen a huge surge in local ordinances that require all electric new construction. This started with the city of Berkeley back in July of 2019, and since then, over 30 cities and counties across the state have passed a similar ordinance, and many more are considering following suit. Another approach that New York City and St. Louis have taken is building performance standards, so requiring certain buildings to meet a minimum level of energy performance and include electrification of appliances and equipment as one avenue for meeting those performance standards. Another pathway forward is through legislation and program creation. Maine is one of the leading states for heat pump deployment, with over 50,000 installed to date, largely because their governor signed a bill that called for heat pump adoption to reach 100,000 units by 2025. As an aside, Maine's success is also a really clear example that heat pumps can and will work in cold climates. And finally, across the U.S., it's absolutely critical that we work to continue to develop a market for heat pumps. We see in New York and Vermont, they're offering remote training opportunities online to help contractors learn how to install heat pumps. And in California, it's committing over $100 million solely to market development through its new tax program under Senate Bill 1477. So these are only a few of the many ways that local entities could support building electrification. Another one that's not listed here is working with your health agencies. You saw how much fossil fuel use in buildings harms human health. I encourage stakeholders to engage with their local air quality regulators to reduce the use of fossil fuel appliances from the public health benefit lens. To conclude, states and cities can deploy a number of different solutions to support the shift to all electric buildings, and we really hope to see some of the same efforts develop and grow here in Oregon as well. We thank each of you for your time, and a big thank you to 350 Day Shoots for putting this conference together and inviting Rocky Mountain Institute to speak. And now we're happy to answer any questions from the audience.
Thank you so much, Sneha and Leah. And I guess the first question we have come in, and I encourage all of you to enter a question into the Q&A or a comment into chat, either one. Our presenters will be sticking around for one or two questions now before we start with the induction range presentation, but also at the end of the presentation. And you can copy the chat where the links have been put. But the question for, and I don't know which of you, Leah and Sneha, would like to answer this, but Ray has asked what suggestions you have or comments on electrifying of the grid or greening of the grid, especially now that electric vehicles are coming on board.
Yeah, I can start us off. Thank you, Diane, and thank you for the question, Ray. So absolutely, I had added a link in the response in the chat, but you know, as of course, one of the things we have to be cognizant of is as we're electrifying, we are now getting rid of the direct emissions of natural gas or propane in our home, but we still have the emissions coming from the power plants fueling the devices. And that goes for electric vehicles as well. There are still emissions coming from certain sources of power on the electric grid. So it's absolutely critical to continue to make sure that our electric grid is becoming cleaner and greener, using more zero emission sources like solar and wind, and relying less on natural gas and power plants. But what I pasted in the chat was also showing that even with today's grid as it is, 46 of the 48 continental states have a grid that's clean enough where if we were to electrify to heat pumps today, we'll already see an emissions savings. So that's a super great sign for the progress that we've already made to date on greening the grid. But I will say there's still work to be done moving that forward. And it's really a great sign to know that a lot of states are taking that action and have intentions to even further green their grid moving forward. Do you have anything to add, Sneha?
I think that covered it. Just one small point is that that blog covers residential heat pumps, and I think also in the chat I put in some information about heat pump water heaters and just some past analysis we were referencing about the economics of electrifying buildings more broadly.
And we have another question too, and I don't know which of you should answer this, but about, someone has asked, Paula has asked about on-demand heaters and if they were figured into your calculation, and she's curious about the emissions from those.
So to clarify, by on-demand heaters, do you mean demand flexibility or? Oh, on-demand water heaters, I see. Well, in that study, we were not considering on-demand water heaters. We were just considering kind of the emissions and cost savings for heat pump water heaters. But we have some kind of ongoing work about the impact of demand flexibility more generally. And we think that's an important part of the solution, and especially for heat pump water heaters in residential context, there's a lot of potential there to incorporate that. But the answer is in this particular study, we didn't include that.
So I think that the on-demand gas water heater has, it seems like there are many that are moving to that rather than putting in the electric heat pump. And so are you suggesting then that you haven't really calculated that yet, but it seems like you're leaning in the direction of electrification, not only from a health standpoint, but from an emission standpoint?
Yeah, from an emission standpoint as well. And in that analysis, which we put in the chat, especially for new construction, there's a pretty good economic case also for using heat pump water heaters. And in retrofits, there's more challenges that are associated with it, but those are also being overcome in various ways.
Okay, and could you, Leah, you have discussed in great detail about really how the fossil fuel industry has sort of convinced everyone that what they do is clean and that it's just a natural bridge to renewable energy. And we know that that is not true, certainly by your research. But can you dive a little deeper into methane and NOx and why that is so dangerous now, why we really should be moving away from fossil fuels?
Yeah, absolutely, Diane. Thanks for asking. So yeah, methane is another greenhouse gas. We talk a lot about carbon, but methane is another greenhouse gas that actually has a greater global warming potential. So essentially meaning, you know, one molecule of methane has a much stronger impact and greater climate consequences compared to one molecule of carbon. And natural gas, or gas, we just call fossil gas now because really natural gives a false sense that it's clean in some way, right?
Yes.
But fossil gas is really just made up of methane along with other, well, it's really made up of methane. And then when we burn it in combustion, we're also releasing pollutants like nitrogen oxides and particulate matter and carbon monoxide. Things that have been found to be incredibly harmful for our health. And we're burning those in our homes when we're using our gas stoves especially, and having really high concentrations of very dangerous gases within the comfort of our home. And so, you know, I think the important thing for us to consider when we think about gas use in buildings really is that health impact and how close we are to very high concentrations of those harmful pollutants. Especially right now with COVID-19, for those of us on the West Coast with all of the wildfires and really harmful air pollution outside, we're spending so much more time indoors and we're getting really high exposure to nitrogen oxides and things that will directly impact our health, increase our risk of asthma, increase our exposure to toxic pollutants. So, you know, the gas industry and the fossil fuel industry has a business interest in keeping these fuels in our homes and in power plants, but we are truly never going to reach our climate goals if we don't phase out gas. And we're also going to continue to harm our own health and our children and families' health and our communities if we continue to use gas in buildings. So really grateful to be asked here to help raise that awareness.
Thank you very much, Leah.